we are going to present how the NetIDE engine works. This is a specific work package from our project, NetIDE work package 4. That is why we have that w.v0.2 there. So in the first part of this demo, we're going to present how this NetIDE engine is intended to work and what are the basic concepts of this engine. And then we're going to present a live demo on how this is working actually in our implementation. So what is the story? Imagine some network administrator is managing already some type of network which is running by using the POX controller framework. But now this network administrator remembers that the company used to have some very fancy application which was developed over the v0.2 controller framework. So she's wondering, how can I use that application over my current system? How can I use that v0.2 application over a POX controller framework? So this is why the NetIDE engine came into place. We can use that POX controller framework already running and try to deploy and test our v0.2 application over that running system. So how can we achieve this? For this demo, we have a single switch topology, and we want to run the single switch application, some layer 2 switch application. We have a single switch with 3 hosts, and our current implementation has that architecture shown in the picture. We have some IDE in which we can develop applications, but we can also store them in some repository and deploy them into our engine. As you can see in the engine, we have 2 main components. We have some controller framework on the top and some controller framework below. On the top, we call it the client controller framework. Below, we call it the server controller framework. Both controller frameworks can communicate via some protocol. In this case, we are using the Pyretic protocol, which is a TCP connection. At the same time, the SIM layer and the backend let the different controller frameworks to do this operation. And the SIM layer have some logger or some other tools installed there. Finally, this network engine connects to the topology. In this case, this is a single switch topology. What is the current implementation of the NetIDE engine? Currently, we have the following client and server controllers. We have Pyretic, v0.2, and Floodlight on top as backend or client controller frameworks, and POX, v0.2, and OpenDaylight as server controller framework. Finally, we instantiate the application we want to use, in this case, the learning switch. So now we are ready to run the demo. In this VirtualBox machine, we have installed our engine, our NetIDE engine. As you can see, we have opened 4 different windows to execute the different components of the system. If we check some of the scripts we prepare, we basically have some script to run RabbitMQ. We will see why we need this. And then we have 3 main scripts. A NetIDE backend script to execute the client controller. In this case, we just choose the type of controller framework we want to execute on top. So we can choose between Pyretic, v0.2, and Floodlight. Then we have the NetIDE shim script, and we can execute POX, v0.2, and ODL. And finally, we have another script for Mininet, although it was not necessary, but we create some script to execute single and linear and tree topologies. So in this case, we are going to execute the single topology, which, as you can see, is a Mininet single topology with 3 hosts, as you can see here. So back to the command line. In this window, we will execute the backend. In this, the shim, that is, in this window, we will execute the client controller. In this window, we will execute the server controller. Here, we will execute Mininet. And finally, here, we will execute some tool, in this case, a logger tool. First of all, we're going to execute this tool. So this tool is already running and waiting for logs, as you can see here. Then we're going to choose Pyretic as our client controller. As you already know, Pyretic is a controller which is run on top of the POX controller. So initially, we could say that we can execute the POX controller framework as a server controller framework. But we're not gonna do that because we already know that this is working because the Pyretic team did it. So we are gonna try something different. We're gonna use, as a server controller, we're gonna use the Ryu framework. And you will see how the Pyretic controller connects to this Ryu instead of POX. So as you can see here, the Ryu client has initialized. The Pyretic backend is not telling us anything, but we're going to start a Mininet topology, and we will see what is happening now. More specifically, we are using the single topology. So it's requesting my password. Now that is introduced, we can see that we have created some topology, specifically the topology we saw before with 1 switch and 3 hosts. And we can see the messages over here. At the same time, we can see the messages coming to the client controller. OpenFlow switch 1 connected. So the Pyretic is actually being connected to the network through the server controller. The client talks to the server and the server talks to the Mininet topology. And at the same time, the server is helping these two and sending all these logs to the tool. So we know what we have in the network. Now we're going to try some pingo. And we will see that the pingo is working. We can see all the different messages over here in the log, which is difficult to read, but you can understand that these are different packet in and packet out messages. And at the same time, the Pyretic client controller is showing some log about this learning switch application. Finally, if we exit the Mininet topology, we will see that the Pyretic controller says that the OpenFlow switch 1 is disconnected. So we're going to close now the different client and servers. We're going to close the logger as well because we don't want to use it anymore from now. And now, sorry about these errors. This is because this is an initial prototype, so we have to close with Ctrl+C. And now we're going to execute something completely different. For example, we'll execute Floodlight as a client controller. This is not usually done because Pyretic is expected to run over some other controller, specifically over POX, and we've run it over Ryu. But Floodlight is a single controller framework, so we're going to run it over some server controller. We could use Ryu as well. If we try it, you will see that this is running as well. So we start the Mininet topology, and we quickly pingo, and everything is working. And we can see the messages over here, we can see that the server is connected, and so on. Finally, we are going to do a final test. In this case, we're going to execute as the client controller Floodlight, and as the server controller, we're going to execute OpenDaylight. Let's put the script first. So we have Floodlight and OpenDaylight. Floodlight is already running, it's already checking if something is connected or not. And as you can see, this is a very peculiar demo because Pyretic is used to have something below, which is the POX controller, but Floodlight is not used to that. So we're going to connect Floodlight to OpenDaylight, and then OpenDaylight will connect to the Mininet topology, and will send back and forth the messages to the Floodlight client controller. If we wait a bit for the OpenDaylight shim layer to start running, because as we can see here, Caraf is waiting for actions and modules to be loaded, but the shim layer is already loaded, so we just have to wait for it to be finally loaded. So now we can see that it says ODL multi-manager starting, and that means that the NetIDE engine is working. In fact, the sim layer is running. So now we can start the Mininet topology. And the Mininet topology will run, and we will see that the OpenDaylight server controller receives different messages from the topology, different switch messages, port join, switch join, and then we will have some communication with the Floodlight client controller. So now these controllers are communicating, and we just need to check whether if this OpenDaylight server controller is in fact telling the Floodlight what it has below. So how can we check this? Floodlight has a web interface. So if we open Firefox, we can in fact check that web interface of Floodlight. And we can see here that the Floodlight GUI is telling us that it has one switch below. In fact, this switch is not below him, because below him is OpenDaylight. So at the same time, we can check OpenDaylight as well, and we will see that OpenDaylight, after introducing the credentials, we will see that OpenDaylight is also seeing one switch below. In fact, Floodlight should see the different hosts, but we are under development for these special messages for the host, because the Pyretic protocols initially is just sending some switch join and packet in, packet out, and so messages. We have to develop the rest. So in fact, as you can see here, both Floodlight and OpenDaylight are showing that they have one switch connected. Finally, if we come back to the Mininet command line, we will be able to try to ping all. And basically, you can see the messages coming to Floodlight. OpenDaylight is not telling us anything because we don't have any log here, but Floodlight is receiving all the messages through OpenDaylight, and all the pings worked. Finally, if we exit the application, we will see some connection closed here, and we can close the OpenDaylight server controller and the Floodlight client controller. And that's all. That's how we make the Floodlight controller talk to the OpenDaylight controller, and at the same time the OpenDaylight controller talk to the Mininet network. So Floodlight is thinking it is controlling the network, but in fact it is talking through OpenDaylight.